Alright everybody, this is section 8.5. We're going to go into polar coordinates. Most students feel like this isn't so bad at all. So far this chapter we've talked about like rectangular form, so our regular standard form. We have trigonometric form that we looked at and used extensively the last couple sections. So what we're going to do now is kind of have a connection of, instead of using a standard rectangular form x-y coordinate where you're given the x value and the y value, polar coordinates come in handy, especially in calculus, if I know the radius and the theta. That tells me exactly where my coordinate point is, just another way to reference it. And then we can have quick ways to find your x and find your y. So this is just a whole bunch of equations. These are things you're going to need to know. You're going to need to know the x value is just your radius times, remember cosine is your x value. The radius tells me how far out it's actually going to go, so you multiply by that factor essentially. The y value, remember, is sine theta, sine is y, and then you multiply by the factor how far is the r value away. Alright? R, how do you guys find r if I just ask for the radius? It's just Pythagorean theorem. X squared plus y squared equals r squared, take the square root. That's where that comes from. How would you guys find theta given x and y? We've done it a million times. Okay? Y over the x, tangent theta equals y over x, so you take tangent inverse. Okay? So all of these are things you maybe have seen or that we will use in this section. We'll try to go through this pretty quickly. Give the polar coordinates for this rectangular form of 4, 4. So if you guys graph this out, I know I'm 4 units right and 4 units up. 1, 2, 3, 4. 1, 2, 3, 4. Here's my dot. How do I find polar? Remember, polar is r comma theta. Do I know my radius? How do you guys find radius? R on the previous page was x squared plus y squared, and you take the square root of that. So 4 squared 16, 4 squared 16, so that'd be 32, right? And this is your r value. So 4 squared plus 4 squared, so r squared equals 32. So that ends up being what? 16 times 2. So the square root of 16 is 4 root 2. So r is 4 root 2. So I know I have the coordinate point 4 root 2, comma. How do I find theta? Theta, remember, is tangent. Theta equals y value is 4 over the x value of 4. If you take theta equals the tangent inverse of 1, you're going to get 45 degrees. Alright? So I know that my theta is 45 degrees. So I could graph the exact same dot if I would go out 4 root 2 units this way at a 45 degree angle, I end up at the same spot. So this is what I mean by a polar coordinate. If I give you the polar coordinate, can you give me the reverse? Can you give me the rectangular form? So you guys got to think about is 120 degrees is what angle? Going this way. Actually, I'm a little too far. So it's 120 degrees, right? My radius is saying that I'm going out 2 units. So then if I come back down, I got to figure out my x value and my y value. Well, this isn't bad. If you guys could do this visually from what we've done before, if you really want to, you're going to know that this is 60 degrees, and you're going to know that the radius is 2. That's a special triangle. So across from it's the square root of 3. That's the 1. So I know that my coordinate point is going to be what? Left 1 up square roots of 3. Alright, so that might work faster, but it's not going to work every time. So what I'd like you guys to see is, how do I find an x value? It's the r value times cosine of theta. The radius multiplied by whatever cosine theta is. So I know it's 2 times, what's cosine of 120 degrees? You may still have to do that, or you could do it in your calculator. It doesn't really matter. I know cosine of 120 is going to be negative 1 over 2. So what's 2 times negative 1 over 2? X equals negative 1, which is what I have. Okay? And then y equals r times the sine of theta. So I know y is going to be 2 again times sine of 120 as well. What's the sine of 120? Root 3 over 2. So what's 2 times root 3 over 2? Y is going to strictly be square roots of 3, which is what I have. This is going to work way better if I'm not giving you special triangles. If I give you special triangles, it might be faster to do that. Alright? So number 3 says, how would you graph it? I don't really give you directions, but how would you graph negative 4 and 60 degrees? So in polar coordinates, you're able to go many directions. If I know I have a 60-degree angle, I know it's that direction. But if my radius, if it'd be 4, I'd be 4 units that way, and my answer would be there. But if it's -4, I'm going just in reverse. So I'm going 1, 2, 3, 4 units this way. And that's where your dot would be. That's how negatives work. So here's another example. If I give you -5 but 150, so 150 is this direction. If it's +5, I just count out 5 that way. But I got to go reverse order. 1, 2, 3, 4, 5. There's my coordinate. All right? So it's as simple as that. If I want to find the rectangular coordinates for them, it's a little bit different. Okay? I mean, it's not any different. It's just it's not as simple. It's not as easy to kind of figure it out. So how would you guys find your x for this one? Remember, r cosine theta. All right? So if I want to go x equals, what's my r? -4. Cosine of, what's theta? You still use the theta in the problem. So it's 60 degrees. Okay? 60 degrees would be what? √3, 1, 2. So what's cosine of 60? It's 1/2. So -4 times 1/2 would be -2. How about the y value? Y equals also -4, but what's the sine of 60? Well, if cosine's 1/2, sine's going to be √3/2. What's -4 times √3/2? -4/2 is -2 times √3. So y equals -2√3. So what is my coordinate point? My rectangular coordinates. If I wanted to go x, y. -2. I'm left 2. I'm down 2√3. Okay? So that's all the negatives doing. You either graph it this direction, but you still can use the information that's there. Okay? So same drill here. If I want to find the rectangular coordinates again, r is -5 cosine 150 degrees. What's 150 degrees? Reference angle is 30, so here's the 1. And here's the -√3, correct? There's the 2. So I need to find this coordinate, though. So that's the tricky part. You need to figure that part out. You could redraw the triangle, or I could just deal with it right here. So I know that the x value is going to be -5 times, what's cosine of 150 degrees? Cosine's -√3/2. I can't really do anything with that one. It's just two negatives make a positive. 5√3/2. I'm over 5√3/2, and then obviously I'm going to go down. So I'm expecting my sine. What's the sine of 150? Sine of 150 is 1/2. So what's -5 times 1/2? -5 halves. So if I ask you what are the rectangular coordinates, these aren't quite as easy. The x value is 5√3/2, comma, -5/2. And that's what it is. Okay, give 3 other polar ordered pairs that will name the same point as 3, -60. You might be like, Wilson, what are you talking about? So let's graph this guy first. I got to go 60 degrees and 3 units out. So there's my original kind of scenario. That's one way I could write it. I'm going 3 units this way, up that far. Okay? 3 other polar pairs that name the same point. Well, you could go the other way. You could have your angle go the same direction. All right? So what if the angle goes the exact same or the opposite direction? What degree measure would this now be? Well, I could write this as 3, -300 degrees. That's one of them. All right? What they mean by this, what other ordered pairs have the same point, means the same distance away on essentially the same line, which means you could go this direction as well. So instead of going 3 units up, we could go 3 units back. It's the same distance of the point. So I could go, how? Instead of going up this way, I could come back, and I still could go 3 units. So what's changing? My r value is changing. I could go -3, comma, and now what's my degree measure going to be if I actually go the positive direction? All right? This is 60. That means this guy's 60. So that's going to be what? 240 degrees. You're 60 units past 180. Or I could go in the negative degree measure distance. So I could go -3, comma, what? Is this 30 and 90? So it'd be -120 degrees. So that's 3 other ways we can essentially describe the distance on this angle measured line. Is the logic behind it. Alright? So number 6 just says convert -1√3 to polar coordinates. Don't make this any more difficult than it has to be. If I give you these -1 and then you're going up √3, 1 over up √3, obviously that's 2. What do you need for a polar coordinate? You need your r value. I know my r value is 2. What's your degree measure here from there to there? Obviously √3 is across from the 60. So you're 60 degrees short of 180, so it's 120 degrees. So just another way to practice going from one to the other. Alright, these last 2 slides are a little bit new, a little bit different. It says change this r squared equals 9 sine 2 theta to rectangular form. Rectangular form means you only can have x's and y's. That's it. We can't have any of these thetas, we can't have any r's, we can't have anything. So the first thing I see is this sine 2 theta. I can't have a double angle. I do have an identity though. I know that r squared equals 9 times sine 2 theta is 2 sine theta cosine theta. So I know that for sure. The problem is I have a sine theta and a cosine theta, and I have r squared. That's a problem. But the only way I can get rid of sine theta is that what? I know that y equals r sine theta. I know that x equals r cosine theta. So what are we missing in front of the cosine, in front of the sine? An r. So I'm going to have to multiply an r to go by the sine. I also need to multiply an r to go by the cosine. So I need to multiply essentially 2 r's to both sides. Okay? So kind of we're going to look at r squared times r squared equals 9 times 9 is 18. But how do I know about r sine theta? It's y. What do I know about r cosine theta? It's x. That's good. This side's good to go. Now I have some r squareds here. If you refer back to your very first page, you guys knew that r equaled the square root of x squared plus y squared. The Pythagorean theorem idea, your radius is square root of x squared plus y squared. Well, I have r squared. What would r squared be? If you square both sides, r squared is simply x squared plus y squared. And I have 2 of them. So basically I could replace them both, and I can say x plus y squared squared, if that makes any sense, because there's 2 of them, equals 18. I'm going to write x first because I want to. As ugly as that is, that's all they want. This is now rectangular form. It's not that they're asking you to solve for x or y, they just only want x's and y's. And the same formulas are the ones we use. Okay? Vice versa, if I give you x and y and want polar form means I only want r's and thetas. So what is an x equal? Alright? What does x equal? I know x equals r cosine theta. So I know r cosine theta plus r sine theta equals 4. Now, arguably speaking, we could be done. I wouldn't even be mad if we decided to be done. I think the back of your book solves for r, though, because that's how you plug it in your calculator. So what's in common? An r. And you get cosine theta plus sine theta equals 4. If I need to solve for r, I got to divide this guy out. So r would equal 4 divided by cosine theta plus sine theta. And then you can actually put in your calculator and graph it. We'll get to that tomorrow, but that's the idea behind it. So solve for r. Alright, last one. Maybe not last one. 2 more yet. Change r cosine theta minus sine theta equals 2 into rectangular form. Alright, so I would distribute the r because we kind of have parentheses. And on the previous page, you guys knew that r cosine theta is just x. We knew that from the identity. We know that r sine theta is just y. And we have a lovely little rectangular form of x minus y equals 2. So sometimes it can be that simple. No different than the last one here. what do I know about x squared plus y squared? Well, I know that just r is the square root of x squared plus y squared. So if I want to just have x squared plus y squared, I need to square both sides. So r squared is x plus y squared, your Pythagorean theorem, different things like that. So I know this whole thing can just be replaced as r squared equals 4x. Remember, polar form means I only can have r's and thetas. What do you guys know about just x? R squared equals 4, what? R cosine theta. So I actually could divide the r out to get r all by itself, and you'd have r equals 4 cosine theta. Alright? That's what the back of the book will probably have, and then we'll deal with what that kind of looks like tomorrow. So, please write me a summary, and any questions that you have, we'll try work on these as a group, and that's the assignment we'll have. Hope you have a wonderful day.